So welcome to the presentation here. Today we will see the characteristics of a PN junction. The PN junction in the symbolic representation can be written like this, and you are quite familiar with this. Wherein this terminal is called as the anode and this is called as the cathode, and this cathode can even be written in the symbolic representation of C. Both are okay. Okay, fine. To find the forward bias characteristics of this, anode of this diode has to be connected to the positive terminal of the external battery, and the cathode of the diode has to be connected to the negative terminal of the external battery. This we call as the battery. This is the diode. To know the voltage drop which is available across this anode and cathode, we can use a voltmeter to record the value. Essentially, it is a DC voltmeter with the positive terminal here and negative terminal here. This is a basic circuit wherein we are having no inclusion of any resistance. That is why it is not a practical circuit. In the practical circuit, we have to have one resistance to limit the current flow through this diode so that the diode is safer enough. Now, we will analyze the behavior of this diode by plotting the graph of the voltage between the anode and cathode terminal as recorded by this voltmeter, taking those readings along the x-axis, and we call as VAK, the voltage between anode and cathode, and the current which is flowing through this diode. If the current is flowing in this direction, we call as the forward current, and that will be taken along this y-axis, IF, the forward current. From the previous video, you know that the junction potential, when it is not at all connected to any external source across this diode, is of the order of 0.5 volts to 0.7 volts. And it depends on the type of manufacturing and the substance which is used for fabricating the diode here. Assuming that any one of these values is the junction diode voltage, say 0.5 volts, we will start the analysis. If the battery voltage, the external battery voltage is starting from 0 volts, it would be as good as not at all biased condition diode. When this voltage, the external battery voltage, is raised in steps of 0.1 volts. These are the steps that I am taking or mentioning. So the first step will be incremented by 0.1 volts. In the next step, another 0.1 will be incremented so that the applied voltage will be equal to 0.1 plus 0.1, it is 0.2 volts. In the next step, another addition of 0.1 volts, therefore the applied voltage will be 0.3 volts, and so on. If we go on increasing the voltage of this external battery, which is applied directly to this anode and cathode terminal of the diode, till the voltage applied from this external battery sources crosses this junction potential, there will be no marginal rise in the diode current. It will be gradually rising, and in the graphical representation, it is not at all rising like this, but it will be gradually rising from the lower value, and therefore during this part it will be having the curve here in the response of the output current or the forward current with respect to the voltage between anode and cathode. Till the opposing barrier potential is totally vanished away, it would not be having any linear rise in the diode current with the rise in the voltage across anode and cathode. The point where this voltage, the junction potential is totally vanished out at this junction is called as the knee point, and that is available here, and this we call as V knee. From this point onwards, any rise in this voltage across the anode and cathode of the diode with the increment of the battery voltage will linearly increment the forward current of this diode, and in the graph we can see the curve to be rising linearly from this point onwards. And from this point onwards we say that the diode is completely forward biased and is in the forward conduction mode. Definitely, the step-by-step recording and plotting the graph of all these variations in a tabular column process or manner. Say the serial number here 1, 2, 3, 4 and so on. We'll be having the voltage between anode and cathode in steps of 0.1 volts, 0.2 volts, 0.3 volts, 0.4 volts and so on. We can record the forward current in generally the milliamperes. Current range will be flowing through these diodes. Whatever the current that you get, you take the recording in the tabular column, and these two readings can be plotted in the two-dimensional graph, and you can see that the graph will be resembling the same curve here, where the point from where the linear rise in the forward current happens is called as the knee point of this diode.